Alrighty, let's start with 2. Okay, part of the linear function g is graphed on the coordinate plane. State the domain and range of the function. So, if we're talking about the linear function, domain and range, so domain is your x, range is your y. So domain, we're going left to right. So I asked myself, can I go forever to the left? No, I'm going to stop here at -7. And can I go forever to the right? No, I stop at 6. Both of these are closed circles, so we go least to greatest. So -7 is less than or equal to x is less than or equal to 6. Then range, we're talking about up to bottom to top, so down to up. So the lowest I go is -4, and the highest I go is +5. So again, least to greatest, -4 is less than or equal to, remember, y is range, is less than or equal to 5. 2, the graph of a linear function f of x passes through the points -7, 0, and 1, 8. Which of the following must be true? The slope is -4/3. Well, I could solve for that if I wanted. The graph of f of x passes through the point -1, -8. Well, I told you 1, 8. I have to figure out if that was true. The y-intercept is 8. Well, the y-intercept is when x is 0. So when it's y is 8, x is 1. So that's not true. The x-intercept is -7. That is true. I didn't have to do any work. I gave you the x-intercept because the x-intercept is when y is 0. Down here, the table shows some ordered pairs that belong to the quadratic function h of x. State the domain and range. I gave you points. This is discrete. You are just going to list the points from least to greatest. So the domain are your x values, and we go -4, -2, 0, 2, 3, 4, and 6. And your range, you are just going to list the y values in order from least to greatest. Well, the least we have -8. There's 2 -7s, so I'm only going to list it once. There's 2 1s, I'm only going to list that once. And then we have 17 and 41. Discrete graphs, you only have to list them. Number 4 says, what is the value of the y-intercept of the graph f of x is equal to 12 times 1/2 to the power of x? So what I am going to do is I'm actually going to type this in my calculator and look at the graph. So I'm going to go to y equals, we're going to type 12, parentheses. We have 1 divided by 2. We always type fractions in parentheses. Then we're going to use the caret symbol right underneath clear to make our exponent x. I'm going to clear out this negative that's in here. And now I can hit graph and look at my y-intercept. Okay, well, it's off my graph. I can't quite see it, so I'm going to look at the table. To look at the table, we're going to do second graph. Remember, the y-intercept was when x is 0. Well, when x is 0, y is 12. So the y-intercept here is 12. The other way you could have done this is you would have plugged in 0 for x, since this is the y-intercept's always when x is 0. We have 12 times 1/2 to the power of 0. You could have typed that in the calculator. Anything to the power of 0, as we'll learn, will be 1. So 12 times 1 is 12. So the y-intercept is 12. But you could have just seen it in the calculator. Determine whether the following graph depicts a function of x. Explain your reasoning. Function, we're just looking at the vertical line test. If I put a vertical line on this graph, I touch multiple points. If it touches multiple points, you're going to say not a function. This fails the vertical line test, or the VLT. Number 6, the graph of a function is shown below. State the domain, the range, the function family, and the y-intercept. Well, the function family is exponential. I can tell just by looking at the graph. Okay, the y-intercept, where we cross the y-axis, well, the y-intercept is at 0, 1. And now we're going to do the domain and range. So starting with domain, you're going to ask yourself, can I go to the left forever? Well, if I push this graph up, it will keep expanding to the left. So yes, it can go to the left forever. If I push this graph out, it's going to keep expanding to the right. So since it goes forever left, forever right, the domain is all reals. Now, the y-intercept, this is what's really tricky about exponentials. When we talk about exponentials, it's y is greater than, because if I look above, I can go up forever. So it is greater than. But here's what happens. I cannot go down forever. I'm going to get closer and closer and closer to a line. We talked about that line is called the asymptote, but I will not cross it. So it looks like I'm pretty much touching 0, but we know I'm not. So the range here, we're going to say y is greater than 0. 0. I cannot touch the asymptote. It's just going to be everything above the asymptote. Number 7, which graph best represents the graph of a quadratic function with a domain of all real numbers less than 4? So we have x is less than -4. Okay, well, domain, we're talking about left and right. So less than -4, I need my graph to be going to the left. So immediately b and d are out. So here, we want our x value to be less than -4. In graph A, our x value is 0, so that one doesn't make sense. C, our x value is an open circle in -4, so that works for the less than. And then it goes to the left, so the graph should be C. 8, the graph of a function is shown below. We're going to list all these characteristics. So starting with domain, if I push this graph out to the left, it will go on forever. If I push this graph out to the right, it'll go on forever. So my domain is all reals. The range, I can push the graph down forever. However, I cannot push up forever. I'm going to get stopped. I get stopped at this point here. So the y value of that point is 6. It is a line, so it goes through that point. So I'm going to say y is less than or equal to 6 because 6 is included in the domain or in the range, but it is not. I can't go above 6. The function family, this is a parabola, so this is a quadratic function. The maximum or minimum, well, it has a maximum because I have a point below, and that maximum is located at the point 2, 6, because that's as high as we can go until I start going down. The y-intercept here is going to be at 0, 4. Now the x-intercepts. Well, there are 2 of them because I crossed the x-axis at 2 points. We're going to learn when we get to the quadratic unit how to be very, very specific in our x-intercepts and how to solve for them. But for right now, I would have accepted negative 1.50 and maybe 5.50. Both of those would have been fine. Number 9, the graph of an exponential function is shown on the coordinate grid. Which line represents the asymptote, the line that the graph gets closer and closer to but never touches? Well, we know that that has to be the lower boundary. So the line that it looks like it's getting really, really close to, but we know it's not going to touch, is going to be line S here. 10, a florist is making bouquets of flowers for a wedding. Each bouquet will have 9 flowers. The graph shows the linear relationship between y, the number of flowers used, and x, the number of bouquets. The florist will use no more than 8 bouquets for the wedding. State the domain and range. This is discrete. It's got dots. All you have to do is list the points. So starting, we had 0, 1, 2, 3, 4, 5, 6, 7, and 8. That was your domain. Then for the range, I just have to list the y values. Well, we had 0, 9, 18, 27, 36, 45, 54, 63, and 72. Discrete, you just list the points. Alrighty, Wildcat sheet number 3. A function is shown. What is the value of g of 20? Well, 20 is inside the parentheses, so we're going to replace that for x. So I'm just going to plug in. G of 20 is equal to 6 times 2 times 20 plus 7. So 2 times 20 is 40 plus 7. I have 6 times 47. I have a calculator. I don't have to do this by hand, so I'm going to do 6 times 47. That's 282. So G of 20 is 282. Number 2, this was a star question. It says a sequence is defined by f of 1 is equal to 27 and f of n is equal to 1/3 times f of n minus 1 for each whole number where n is greater than 1. List the first 4 terms of the sequence. Okay, n is your term number. Well, in fact, I could plug in my next term. Well, I know the first term. I told you f of 1, so the first term is 27. Now I'm going to go ahead and plug in f of 2 is equal to 1/3 times f of 2 minus 1. Well, 2 minus 1 is just 1. Well, don't I know what f of 1 is? Well, f of 1 is 27. So really, I'm just going to be doing 1/3 times 27. 1/3 times 27 gets me 9. Now I can start to see a pattern. This is just the recursive sequence. So I'm going to do 9 times 1/3, which is 3. 3 times 1/3 is 1. And that is the first 4 terms of the sequence. The question was not asking you to do a lot. It was just worded a little bit difficultly. Which statement about the function n of x is equal to 5x squared minus 20 plus 12 is true? Okay, I am going to go ahead and look at the graph by typing this in for y equals. So I'm typing in the equation they gave me so that I can see the graph and make some conclusions about it. The domain of the function is x is greater than or equal to 2. Well, I know these graphs, if I push to the left forever, it's going to go on forever. If I push to the right forever, it's going to go on forever. So this is all real. So I don't think that is quite right. The range is n of x is greater than or equal to negative 8. Well, down here, I'm at negative 8, and everything above it seems to be part of the graph. That seems like a good choice. Again, we talked about the domain is all real, so I'm going to say C is no. The range is n of x is less than or equal to 12. Well, that would mean my graph has to point down, so that doesn't work. So our answer is B. Isaac is playing video games at an arcade. The amount of money Isaac has remaining can be found in the equation y equals 20 minus 0.5x, where x is the number of games Isaac has played. How many games until he spends all his money? If he spends all his money, he has $0. So what I'm going to do is I'm going to put 0 in place of y and just solve it like an equation. So to do that, I'm going to subtract 20 from both sides. So I get negative 20 is equal to negative 0.5x. So divide both sides by negative 0.5. And when I put that in the calculator or you solve that, you would get x is equal to 40. So Isaac can play 40 games before he's out of money. A Petri dish is filled with 250 bacteria cultures. The number of bacteria in the dish triples every hour. Write a recursive and explicit formula to represent the sequence that models the scenario. Okay, this is geometric. So when we talk about the recursive for geometric, we're going to say G sub n is equal to our common ratio. Well, the common ratio here is triples, is equal to 3 times we have G of n minus 1. Okay. The explicit formula, we have G sub n is equal to the first term. Well, the first term in this case is 250 times 3 to the power of n minus 1. Okay, now I have predict the number of bacterial cultures in the dish after 8 hours. Okay, so what I am going to do is I'm going to plug in 8 for n. So G of 8 is equal to 250 times 3 to the 8 minus 1, which would be 7. So we have 250 times 3 to the power of, 7. And I get 546,750. Number 6, the first 16 terms in a geometric sequence are shown where a sub 1 is equal to negative 4. Based on this information, which equation can be used to find the nth term in the sequence a sub n? All I could do here is simply just plug in the term numbers and see which one gets me the correct answer. So they all are starting with negative 4, so let's try the second term. So this time I would have a sub 2 is equal to negative 4 times 2. Well, negative 4 times 2 is negative 8. That's not what my sequence has, so the first one is incorrect. This one, a sub 2 is equal to negative times 4 to the power of 2. Well, 4 to the power of 2 is 16, and then I get a negative 16. That's pretty much what I wanted, so let's see if that continues. This one, a sub 2 is equal to negative 2 squared. Well, negative 2 squared becomes negative 4. That's not the second term of the sequence. And then B here, we get a sub n is equal to parentheses negative 4 squared. Well, that would get me a positive 16. So D is not correct. We have B. Number 7, a lot of people struggled with this. It says sketch the graph with the following domain and range. X has to be less than or equal to negative 4, and Y is greater than or less than or equal to 2. Okay, you cannot have one endpoint for this because they have different signs. This one has to be an open circle, whereas this one has to be a closed circle. So what I am going to do here is y is less than or equal to negative 2, and x is less than negative 4. So that means x we have to be going to the left, and y we have to be going down. So how I'm going to do this is I am going to put an open circle on negative 4, but then I'm going to need like some kind of hump so that it can go to -2 and then go down. So I'm going to put an open circle here at -4, -5. So there's my x value. But then I'm going to take my graph and I'm going to go up to where I cross through -2 and then go down. Cross through and go down. So now the x values, well, we're forever to the left of -4. But for my y values, the highest I can go is equal to -2 because the line goes through it, but then I go forever down. Number 8, which statement about p of x is equal to -7 times 4 to the power of x is true? So I'm going to go ahead and plug it in the calculator. We're going to look at the graph. So we have -7 parentheses 4 raised to the power of x. Look at the graph. The domain is all real numbers greater than or equal to 4. Well, if I push forever to the left, it's going to keep going. If I push forever to the right, it'll keep going. So the domain is all reals. The range is all real numbers less than 0. Okay, we know that when we get an exponential graph, we have this asymptote where a line that looks like it's touching, but it's not. And then we have below that is 0. So we could say that y is less than 0. That looks like a good choice. Again, we just said the domain is all reals, so C doesn't make sense. The range is not all reals because we have that stopping point, so B is the best option. 9, the domain and range of part of a linear function are given. X is greater than or equal to 5, and Y is less than or equal to 2. So I know my arrow has to be going to the right for X to be greater than or equal to 5, or greater than 5. And my arrow has to be down for y to go less than 2. Well, this arrow is going to the left and up. That's not right. This one goes to the left and down. Yeah, it should be going down, but I need to be going to the right. This one goes to the right and up. Nope. So the only option here is this one. Number 10, in her first week of gym training, Consuela can do 25 sit-ups per minute. During week 2, she can do 29 sit-ups. By week 3, she is up to 33 sit-ups. Consuela continues to increase the number of sit-ups she can do each week and follows the same pattern. Use the numeric sequence to represent the number of sequence she does per minute for the first 5 weeks. Okay, sequence. I'm adding this time, so I'm going to do 25, then I add 4 to get to that 29, add 4 to 33, add 4, that's at 37, add 4, that's at 41. There's the first 5 terms. Now, does the sequence meet the definition of a function? Explain your reasoning. Well, if I'm just adding 4 every time, I'm never going to repeat our x values because the x values are those term numbers. So yes, it is a function because the term numbers will not repeat. In fact, none of it will repeat because I'm not going to go back down. Okay. All right.